Let's go to question number 10, 11. Capacity to ship package within the days. This is medium question, and then this is very popular. Okay, let's get into it. A conveyor belt has packages that must be shipped from one port to another within D days. The ith package on the conveyor belt has a weight of ith. Each day we load to the ship with packages on the conveyor belt in the order given by weight. We may not load more weight than the maximum weight capacity of the ship. Return the least weight capacity of the ship that will result in all the package on the conveyor belt being shipped within the days. So, okay, let's check with the example 1. Input weight is this one, and then within the 5 days. This one is quite similar. Okay, let's say that is the number bucket, and then at that time we needed to prepare 5 bucket, right? And then we needed to put all of them. So in this case, maybe if we the 15 is the we needed to 1 2 3 4 5 6 4 is this is 10 15, so 1 to 5 is going to here, and then 6 7 is going to here, right? And then 8 9 cannot, 8 going here, 9 going here, 10 going here. That is maximum. That is the optimum, right? So we will gonna to do this one. So I think proper solution is, I think that we just do a looping loop. So the first loop is we checking the one by one, and then while iteration we need to find one, and then the better way is we able to use binary search. Is it possible? Yeah, that's right. Okay, this one is looks like ascending order, but okay, let's check example 2. Example 2 is that this one is not ascending order. So it looks like that we cannot use binary search, but okay, let's think a little bit differently. So now this is 5. We need to make the 5 bucket, and then to fit this one, and then maybe we can find the minimum of the bucket size and the maximum is the bucket size. So okay, let's say which one is minimum. Minimum is, let's say, the left minimum is the must be 10, because if bucket size is smaller than 10, we cannot put this one, right? So let's say minimum is 10. From 10, what is maximum? Maximum is the case we put all item of weight to one bucket. That is same as sum of weight. Does this make sense? So we will do this one is right, and then we do binary search with this one. So first is find the middle number. This one is the 55, right? And then this one 10 is the middle number is 65, and then 64, and then middle is 32. And then first we assume the bucket size is 32, and then we fill one by one. And then maybe 32 is maybe we need 2 or 3 bucket, then that means we able to reduce it, right, to 15. And then when you find the 15, we return this value. Does this make sense? Okay, let's implement the code. First, the left is the which one? The biggest of the item, right? So left is max weight, and then right is sum weight. Then we'll do binary search. Left is right, and then mid is get middle value, and then now we needed to fill bucket, right? So bucket count is start with 0, no 1, because first we needed to put one bucket to put it, right? So, and then inside of the bucket counter is this 0. And then I will do fill one by one from the weight, and then until count current fill bucket. Okay, let me draw it. This is bucket, and then bucket index is, this is first bucket, and then count first is count 0. This is count, and then until this is count plus W. W is, that's right, this is below than mid side, we can fit it, right? So this one means count plus W is small equal than mid. We can able to fit it. Count is W. Otherwise, we need to prepare a new bucket and then put it. Does this make sense? Okay. And then I will do binary search with the bucket. So if bucket is bigger than D, that means even we need 5 bucket, but it used this 6. That means what about the bucket size? Bucket size we need to increase or decrease. Okay, this means bucket size is the smaller than we expected, right? So at that time we needed to increase bucket size to reduce bucket. Does this make sense? To do that, if a bucket size is bigger, we needed to, that's right, increase the mid number, the left number, right? So mid plus 1, because mid is the cannot fit, so we needed to add plus 1, else right is mid, because if this is satisfied, maybe we're looking for the smallest one, right? So to do that, and then return left. Shall we return right? Yeah, it's okay, because it will exit left equal and right, so anyone is okay. Okay, let's check the code. Okay, looks good. Okay, time complexity is big O, log, left, right, right. So right is sum how can I say, sum weight minus max weight multiply number of weight, because the left is the max weight, right is sum weight, right? And then we do binary search. We take the log n, and then but inside of there, we needed to fill the bucket, so that is the number of weight. So this one is n, and then it's quite similar the log this range, and then space complexity big O 1, because we do not use any data structure. Thank you.